So in the first video for this chapter, or for this section, we looked at combined variation, and let's actually look at one last combined variation problem before we move on to talking about joint variation. But in this situation it says a hyperfocal length h in yards varies directly with the square of the focal length L in inches and inversely with the selected aperture F. So we need to write a general equation here. Remember, it says varies directly, which means that's going to equal k times something, and inverse variation means that equals k divided by something. So we're going to set, so for our general equation we would say h equals k times the square of the focal length L, so it'd be L squared, and inversely with the selected aperture F, so it'd be divided by F. So now we want to find out what k is, so we're going to plug these numbers in to figure out what k is. So it would be 12 equals k times 1.75 squared divided by your aperture, which is set to 9. If I do the math, what I can do is I can multiply both sides by 9 just to make things go a little quicker here. So now I get 108 on the left equals k times, and 1.75 when I square it is 3.0625. Divide both sides by 3.0625 gives me a value of k of approximately 35.3. Okay. So now we want to come up with a variation formula, so we would write this down. We would say h equals 35.3 times L squared, don't forget the square, and we have divided by F. Okay, so now we want to figure out the answer to the question. It says find the hyperfocal length needed in yards if you want to shoot with a 12-inch lens, an aperture setting of 2.5. So I'm just going to plug these numbers in. So it's going to be h equals 35.3 times the length, which is 12 squared, all divided by 2.5. Again, you want to make sure you do this correctly on your calculator. If you don't have a CAS calculator, you'll want to take 35.3 times 12 squared, and then hit enter, and then hit divide by 2.5. Otherwise, it's not going to divide this correctly. Otherwise, if you hit control and divide on your calculator, that'll give you the fraction bar. Allow us to put some items on top and on the bottom, and so in that way you can guarantee that you get the right answer. And again, for this one you should get approximately 2,033 yards is your answer. Okay, so that was all dealing with combined variation. Just to review, combined variation does just like what it sounds. It combines both direct and inverse variation into one problem. On the other hand, joint variation is where only direct variation occurs with two or more variables. So remember, direct variation means equals k times something. Well, varies jointly is what we'll see here. That means that it's also going to equal k times something, but it's going to be more than one variable that we multiply together. So that's why I said k times something else. So let's look at doing this problem. It says the volume of a solid with a circular base varies jointly as the height of the solid and the square of the radius of the base. Sounds like a mouthful, but let's break it down and make it a little easier. So we have the volume, V equals, varies jointly. So when you see that phrase varies jointly, don't forget there's a k involved. So it'll be k times the height of the solid, so h, and the square of the radius of the base, so times the radius squared. Next, we want to find out what k is. So we're going to plug these numbers in to find k. So it's going to be the volume, which is 75.4, equals k times your height, which is 6 meters, times the radius squared when the radius is 2, so it'll be 2 squared. K times 2 squared, or k times 4, gives us 24. Divide both sides by 24, and you get k equals approximately 3.14. So part C, it says what value for k is this closest, is approximately equal to what famous value of k, famous value. We would just say it's approximately pi. So a specific equation that we could have here now would be volume equals pi. Technically, we would say r squared times h, or h times r squared, same thing. And what solid figure would this be? Can you think of it? Nope, it's not a sphere. It's not a circle. it is a cylinder. Because we would take the pi times the radius squared, that gives you the area of the base. For a cylinder times the height would give you the volume. Okay, why don't you guys work this problem out, this last example. And so pause the video and then we'll check your answers here in a minute. Okay, for this one we see again varies jointly. That means equals k times a bunch of items. So this one's again dealing with volume. So it's going to be equals k times the height of the solid and the square of the radius. Now you might say, well, wait a minute, it's the same problem that we were just working on. So isn't k pi? I don't know. Let's see. It says that the volume of the volume is approximately 47.1 when the radius is 3 and the height is 5. Find the value of k. So let's plug these in. So we get 47.1 equals k, which is what we're trying to find, times your height, which is 5, times the radius squared, which is 3, so let's be 3 squared. Three squared is 9 times 5 is 45, so you can say k times 45 or 45k. Divide both sides by 45. We get k equals not 3.14, but you get 1.047. Now it says a value of 3k is approximately equal to what famous mathematical value? So if I take 3 times 1.047, that gives me 3.14. More pi. So I want to figure out how can you express k in terms of that value? So if you think about it, 3 times the answer that we just got would give it 3.14, or 3 times the value for k we just got equals pi. So if I want to figure out another way to look at k, I could say k equals, if I divide both sides by 3, I could say k is equal to pi over 3. And if you took pi over 3, sure enough you get 1.047. So we found out what k is. So variation formula would be v equals pi over 3. Or actually, you know what, a better way to write this would be to say 1/3 pi. Means the same as pi over 3, but you might recognize this equation better. Times h times r squared. Now, can you figure out what the volume of this would be? It's not a cylinder. We already talked about that one. That was pi times the radius squared times the height. But this is 1/3 of that. And actually what this would be is this would be the volume of a cone. And by cone, they're talking about more like this kind of an ice cream cone. Okay, so hopefully that helps you understand. Just again, just to review the key points here. Joint variation is where we have k times our variables, but no dividing, no inverse variation is involved here. But combined variation is where we combine both direct and inverse variation into one. So hopefully this helps you understand this last section for Chapter 2, and good luck.